Hello, my name is Duff, and today we'll be going over Boolean wires. Boolean wires is another logic mod, and it's not really that hard, although it
In
can
reality,
be
all
a
he's doing is pushing the same buttons he always has. Nothing has changed.
bit hard to understand at first. So, this is edge dependent. Okay, so we have 2 and 2. Let Micah say and Sig. And I believe, yep, okay, 0 on 1. Juliet Zulu 5, Zulu Juliet 3. Now then, before I even get started, I should mention, I should tell you how when I say something, to submit something, how to submit it. So when I say to submit an OR, you would cut this wire, this wire, this wire, this one, this one, and this one, leaving only the two diagonals going to top left and top right uncut. If I tell you to submit an XOR, the ones you would leave is the exact same ones as OR plus the bottom line, or bottom wire. The way you submit an AND is by cutting, leaving the uncut ones being the ones going to bottom left and bottom right. If I tell you to submit a NOR, you're going to cut the ones that make an arrow pointing down, so that being the two diagonals going top left and top right, and the wire in the middle. If I say to submit a NAND, you can leave any of these vertical ones uncut. However, it has to be exactly one of them. So it can be this one, it could be this one, or it can be this one. So this would work. Is there any operator that I'm missing? Nope, that covers it. And, while I'm still on the subject of submitting, you can only submit OR, so this once, along with NAND. So this once. But let's actually go on with the manual. So what we want is for the entire logic statement to be true. And if you don't know how logic statements work, I suggest you watch the logic tutorial by Elias. He did an amazing job. So we take the condition for M, or Mike, that being serial port present. We do in fact have a serial port, so we're going to write down true for that. Or 1 if you like doing it that way. Then we take not P. An exclamation point means not, in case you don't know. And not P is going to be a lit FR Quebec indicator present. That is false or 0. Now we can submit it in any one of the following ways. We can do NAND, we can do XOR, or we can do OR. Yeah. However, the way I usually do it is I leave OR and NAND to the last 2 stages. I should probably mention that this module is 5 stages, always. So now that we determined that we have 1 and 0, and that we want it to be true, we cut an XOR. And then, once you want to submit your answer, you cut the green wire.
What? Really?
Bruh. Ignore that strike. I may or may not have already struck on the first example. But, what I said still applies. So, Before I go into the letters, if there is an exclamation point beforehand, it's going to be you're going to use the opposite value of it. So, uh, so if there is so if y is initially true, and there's an exclamation point behind it, well, in front of it, then it would become false, and vice versa. False would become true. This module has 5 stages in total. If you want to reset an input, like you cut something wrong, like this for instance, you just press the red. When you want to submit an answer, you press green. So right now we have J and Y. So we go to where J is. If the number of modules on the bottom is prime, that is false, or 0. And Y is if the number lit equals number of unlit. That is also false, or 0. We can submit it in one of the following 3 ways. We can submit in NAND, NOR, I guess in the following 2 ways. Now, what I usually do, and I suggest you do as well, is save NAND and OR for the last 2 stages. So for stages 4 and 5, so you have to do less work. Since we know that we want the equation to be true, and 0 NOR 0 is 1, we can just cut a NOR. And I'll give you new letters. So we have not whiskey, okay. So if a PS2 port is present, that is false, because we don't have a PS2 port present, but now it becomes true because it's there's an exclamation point. Next thing we have is Romeo. Romeo is if the number of modules is divisible by 3. That is false, 1 is not divisible by 3. So, the 3 ways we can submit this is NAND, OR XOR. Again, since we want to keep NAND and OR for the last 2 stages, we can just get rid of these. So the one we want to submit is XOR. Oops. Next thing we have is DNM. I should mention, by the way, if you do strike on this, it is a full reset. Okay, so we have the letter D, which is the number of modules on the bottom is even. That is false, 1 is not even. And next thing we have is an N. N is if there is a duplicate port on the bottom. That is also false. So we have false and false. So we can do a NOR, since 0 NOR 0 is 1. Now then, like I said, we want to save work on the stage, so we can only and since we have OR and NAND, we really only need to grab one letter. So we have V. V, the number of solved modules is even, so that is true. And since OR is always true if there's at least one true, we can just submit OR. Now we have not November. November is if there's a duplicate port on the bottom. That is false, so now it becomes true. And then we have Charlie. The last digit of serial number is even. That is false, so now we yes, and that is false. And we still have a NAND, and NAND is true as long as both are not true, so we can just submit a NAND. Had I did it the other letter first, so Charlie first, and see that it came up false, we could have just submitted a NAND from the beginning.
This was exactly the way right now.
Let's do a second example.
This is the story of a man named Stanley.
Okay, so we have 3 and 2. An unlet CLR. And Golf Foxtrot 0, Bravo Papa 0. Thank you, OBS. So, first thing we have is DC. D is true if there's an even number of modules on the bomb. 1 is not even, so that is false. C is true if the less than zero number is even, and that is true. Now, since we have exactly 1 true, we just submit XOR. We have not V and not J. Not V is, okay, so if the number of submodules is even, that is true, but since it's not, it becomes false. And, yep, it's not J. And if the number of modules on the bomb is prime, 1 is not prime, so this is false, but then becomes true. False and true, again, is XOR. We have D and T. We already know that D is false, if I remember correctly. Yep. So we have false and true. Well, not true, but T. If there's more than 71 modules, let me count this real quick. We have 1, 2, 1. So, we have less, so they're both false, so we can just submit a NOR. We have not my. Mike is if there's a serial port present. That is false, so now it becomes true. And since we are in the last 2 stages, we can just submit an OR. And we have not S. There's more modules than starting time in minutes. Zen mode's tricky, so I'm going to assume that it starts at 0 minutes for this. So we have 0 minutes as a starting time. There's more modules, 1 is greater than 0, so this is initially true, but then becomes false. So we can just submit a NAND.
This was exactly the way right now. The thing was meant to happen.
And that is Boolean wires. I hope you learned it. If you have any questions, leave them in the comments and get a job.